Number line model. So we would like to illustrate 5 minus 3 equals 2. So remember, when you draw these lines, make sure they're on top of the number line. Don't put them on the number line, but over the number line. So 5, you always start from 0. 5, you come all the way to 5. The subtraction tells us to turn around. So now we're going to go in the opposite direction, 3. So that would put us at 2. So 5 minus 3 is 2 using the number line model. Multiplication is repeated addition, the repeated addition model. So you could go the long way and say 8 plus 8 plus 8 is 24, or you could do it the short way by saying 3 times 8 is 24. This is like a shortcut. Multiplication is a shortcut for addition. You could also use the number line to illustrate this. Notice you start at 0 always. So you go 4, you go another 4, another 4, another 4, another 4. So if you go 1, 2, 3, 4, 5, 4 times 5, that would give you 20. Rectangular array model, you draw these vertical and horizontal lines, and you keep your eye on the intersection, these points that are highlighted. So there are 4 vertical points, 1, 2, 3, 4, and there are 3 horizontal points, 1, 2, 3. 4 times 3 equals 12 intersections. This is the area model. Notice this time we're going to concentrate on these tiles. You could call these tiles. The number of unit squares that fill up the grid is 3 times 5, 15 tiles. This is a 3 by 5 grid. The Cartesian product model works this way. In how many ways can you pair 2 types of bread and 3 condiments? So we're going to use a real life situation, right? How can you pair 2 types of bread with 3 condiments? Here are the types of bread, light bread, dark bread. Here are the condiments. So how many ways can you pair these 2 sets? So Cartesian product has this symbol. It's not a times. We say A cross B, or you could say the Cartesian product. So it says pair up set A with set B. We're going to pair up these 2 groups where set A comes first. So here it is, 2 times 3. You could end up with 6 different pairs of bread with a condiment. The distributive property of multiplication over addition. Right here, what these diagrams show is a convincing way to show why when we distribute this 5 over this addition, 5 times 3 plus 5 times 4, and we add them, this is convincing because you could see. So take a 5, there's 3 here, there's 4 here, so 5 vertical, 3 horizontal, and then 4 more horizontal. So notice 3 plus 4 would be these 3 plus these 4. So if you were to actually break them up into 2 parts, the original diagram, the 3 will still be here and the 5 would be here. The 5 hasn't moved and the 4 is here. So you could do them individually, and notice this would be 5 times 3 is 15 plus 5 times 4 is 20. So if you add them, you would get the total number of squares in the original diagram. Division of whole numbers. Set partition model. Well, when you see the word partition, that implies you're going to be parting, that means cutting, separating, dividing. How would you illustrate 18 divided by 3 equals 6 using the partition model? Well, you could do it, say it different ways. Here are two ways. Partition 18 into 3 groups. So break up the 18 into 3 groups. Then each group has 6. Or 18 cookies partitioned, I mean, it's broken up into groups. 18 cookies partitioned into 3 bags means each bag has 6 cookies. The missing factor model can give us the definition of division. So the definition of division is very important, and the missing factor model can help us. So right here, we don't have anything missing, but we could start off by asking, why is it that 6 divided by 3 equals 2? Why? Because we memorized it? Because they told us? No, there has to be a better reason. Because 6 equals 3 times 2. So if we were to change it into a question, it would be, what is 6 divided by 3? Well, we know it's some number. Some number, right? So it would be because 6 equals 3 times some number. So you could put a variable here instead, if you like. And this would be the missing factor, this one. So now in a general form, A divided by B equals some number because A equals B times that number. Of course, with B not equal to 0, we can never divide by 0. And this is very important. This number that you get, the C, has to be unique. In other words, you have to trust that if you say 6 divided by 3 equals 2 today, that tomorrow 6 divided by 3 is still 2. It's unique, it doesn't change. Now we're moving into the division algorithm. So we start off with this form of division, A divided by B equals Q. Now in this form, here's a division in another form. So the A goes inside the box. This is the dividend. This is a divisor, and this is a quotient, and this is a remainder. So the B goes out here. The A goes in here. The Q goes up here, and the R is the possible remainder. Now, if this is the case, then we should say that A equals B times Q plus the remainder. So A equals B times Q plus the remainder. So we're writing it out. Now this part here that looks kind of strange, this is necessary because you don't want the division to go on forever. It needs to stop. This is a stopping mechanism. And how do you know when you stop a division? When the remainder equals 0. Okay, so that's this part of the inequality, when the remainder equals 0. Or when the, notice the B where it is, when the divisor is greater than the remainder. You could stop for that reason too. So either the remainder is 0 or the divisor is greater than the remainder. Why can we not divide by 0? Well, try it. Let's see what happens. 3 divided by 0, we would say, suppose you were wondering, well, it equals something. I don't know what it is. It's strange. It equals some C. Okay. So if we're saying that 3 divided by 0 equals C, turn that into a multiplication, that would be because 3 equals 0 times C. And remember, C had to be unique because C should be unique. But any C you pick here, it doesn't matter which one, times 0 is not going to give you a 3. So we don't have a C out there that's unique that will give me a 3. Actually, it doesn't even give me a 3. So there's no solution. It's not a unique C. There's no C out there. So there's no solution because it doesn't exist.